Interpolation is a concept that is solved with the help of an integration. Connecting the data points is called as an interpolation. Interpolating the values of one data point with the values of another data point is called as interpolation. Hello everyone, it is Dr. Ravi Kumar Vaibi, Department of Computer Science, Vidhyaashram, First Grade College, MYSURU, the Temple of Excellence. In today's class, we shall learn about the different topics of bracketing methods, in which you also have the interpolation. What is the meaning of interpolation? Let me explain you about the concept of interpolation in detail. Here, interpolation is a method of fitting the data points. What is the meaning of a data point here? Let me consider the value of x here. X equal to 0, 1, 2, 3, so on. If that is the case, if these data points are to be represented along this plane, that is along xy plane, on this plane, there must be some value along the y-axis. So in order to represent these data points on xy plane, I have to have the values of x and I have to find out the values of y from x. How can I find out that? Through interpolation method. The value of a function. It has a various number of applications in engineering and science that are used to construct new data points within the range of discrete data set of known data points, that is x, or can be used for determining a formula of the function that will pass from the given set of points x comma y. That is, the function is defined by y is equal to f of x, where x is the value, where x is a value whose function determines the value of y. That means the value of x and y can be obtained on the data points, that is on xy plane, by using the value of f of x. F of x, we are going to get the value of y. In order to get the value of y, in order to apply the function of x, we must know the value of x, that is the prior value or some initial values. In this article, in this slide, we are going to discuss the meaning of interpolation in statistics, its formulas and uses in detail. We also explain you or read about the extrapolation, statistics, polynomials. These are the applications of this. Interpolation. If that is the case, interpolation is a method of deriving a simple function from the given discrete data set such that the function passes through the provided data points. This helps to determine the data points in between the given data ones. Which is that given data one? This is the given data 1, 2, 3. How I am going to determine the data points? By using the function f of 1, f of 2, f of 3, I am going to get the values of y. If I get the values of y, I will plot these points and I will get the points on the plane xy plane, that is the points like this. Like this. This may be one of the curve. So if that is the case, in some cases I may get the points in this manner or some points in this manner. So that all depends on the function which I am using there. So if that is the case, this method is always needed to compute the value of a function for an intermediate value of the independent function, that is f. In short, interpolation is a process of determining the unknown values that lie in between the known data points, the value of x0 or x1, x2, x3, x4, so on and so forth till xn. If that is the case, the function of these points, these data points, determines the value of y1, that is y1, y2, y3, y4, y5, so on till yn. Yn. So that is the one I am going to use. It is mostly used to predict the unknown values for any geographical related data points such as noise level, rainfall, elevation, and so on. All these are some of the important applications that requires the concept of interpolation. Interpolation is a concept that is solved with the help of an integration. That is this. A linear interpolation formula is given by y is equal to y1 plus x minus x1 divided by x2 minus x1. Please observe this carefully. I have x here, x1 here, x2 here. I have the multiplication symbol here, that is multiplication of this, that is y2, y1 are the two values. And which is the value I am going to determine? Y. Because I have the value of x, x1, x2, y1, y2. With these known terms, I am going to determine the value of y. If that is the case, similarly, the Lagrange interpolation formula is given by, in terms of Taylor series expansion. If that is the case, x minus x1, x minus x2, x minus x3, so on up to x minus xn divided by x0. I have the one term, that is x is the old term, x0, x1, x2, x3, x4 are the terms I am using here. If that is the case, I am using on the denominator. I have the first term, which is considered as a first term. This is considered as the next term. This is considered as the next term. So if that is the case, this is the first term. So first term is beginning with 0. So in the denominator, I have x0 minus x1, x0 minus x2. This is multiplied by y0. Since it is the term x0, I am multiplying it by y0. Similarly, in the denominator, x1 is the next term. x1 is the next term. So x1 minus x0, x1 minus x2, not the other term. Leaving this term, that is, I cannot do x1 minus x0 because x1 minus x1, it becomes 0. Entire thing multiplied becomes, denominator becomes 0. So I can't do that. x1 minus x2, x1 minus x3, so on up to x1 minus xn is done here into y1. That is the concept I am using here. Again, in the denominator, x2, this is the second term. So I need to consider the second term, x2 minus x0, x2 minus x1, x2 minus x3, not x2, excluding that. Then similarly, so on till x2 minus xn, followed by yn. Then this defines the denominator. If that is the case, what is the numerator contains? I have the first term here, x0. So x is the value I am going to consider here. X minus x0, x0, I have to leave that x0. Then x minus x1, so on up to, this is x2. Then x minus, so on up to x minus xn. If that is the case, which is the first term numerator? This is first term, that is x1. So if that is the case, I have to leave x1. Then x minus x0, x minus x2, so on up to x minus xn. Again this term. This is the second term. So I am leaving x2. If that is the case in the numerator, x minus x0, x minus x1, x minus x3, so on up to x minus xn. That is the case formula I am considering here. This defines the value of y. If I further expand this for Lagrange's interpolation formula, which is expressed in these terms, that is x0, x1, x2 terms. This linear, there are different types of interpolation method. The first one is linear interpolation method. Second one is nearest neighbor method. In case of linear interpolation method, it applies a distinct linear polynomials between each pair of data points for curves within the set of 3 points for surfaces. That is the one I am using here. Next, nearest neighbor method. This method inserts the value of an interpolated point to the value of the most adjacent data point. Therefore, this method does not produce any new data point at all. So, we are not going to consider this. We are going to consider this linear interpolation method. Let us see how this linear interpolation method works. Cubic spline interpolation method is the next method. This method fits a different cubic polynomial between each pair of data points x, y, or between sets of 3 points for surface, that is x, y and z in case of 3-dimensional images. This is in case of 2-dimensional images or plane, 3D planes. Now, shape preserving method. What is the meaning of shape preserving method? This method is also known as piecewise cubic Hermite interpolation. In short, piecewise cubic Hermite interpolation, that is PCHIP. It preserves the monotonicity and the shape of the data. It is for curves only. For any curve like these kind of operations, this shape preserving method is used. Then thin plate spline method. This method consists of smooth surfaces that also extrapolate well. It is only for surfaces only. Then biharmonic interpolation method. This method is applied to the surfaces only. Then let me consider one of the example, that is the value of x is considered like this, that is x0 equal to 0, x1 equal to pi by 4, x2 equal to pi by 2. If that is the case, I have to find out the value of y. What is the value of y0? What is the value of y1? What is the value of y2? All these must be determined here. How can I determine the value of y0 from x0? Using the function. Which is that function? Cos of xi. That means function is cos of xi. That means cos of, what is the value of x0? That is I equal to 0, x0. What is the value of x0? That is cos 0 is equal to 1. It is obviously equal to 1. Then similarly, cos of x1, in place of I have 1 here. What is the value of x1? It is pi by 4. Cos of pi by 4 is equal to what? Root 2 by 2. If I further simplify this, I'll get 1 by root 2, the value of this. Similarly, cos of pi by 2. What is the value of pi by 2? Cos of pi by 2 is equal to 0. So, if that is the case, I have found the values of this. Y is equal to cos of x0 or xi. If that is the case, what is the cos of x0? That is 0 is equal to 1. That is y0 is equal to 1. y1 is equal to 1 by root 2. y2 is equal to 0. If that is the case, I have found the values of x0, y0, that is x, this is x, this is y. In case of this 0, 1, 2, x0, I have 0, 1, it is pi by 4, it is 2, it is pi by 2. If that is the case, what is the value of y? y0, it is 1, y1, it is 1 by root 2, y2, it is 0. So, we have these terms here. If that is the case, I have found the values of y0, y1, y2 from x0, x2, x1, x2 using the function cos. Similarly, if I have the function like sine, what has to be done here? Sine of x0 plus cos of x0 by 2. If this is the function, what has to be done? If that is the case, let the values of x0 is equal to 0, pi by 4, pi by 2. If that is the case, what happens here? That is sine of 0 plus cos of 0 by 2. 0 by anything is 0. This whole term becomes 0. Sine of 0 is what? Sine of 0 is 0. 0 plus 0 turns out to be 0. If that is the case, y is equal to 0. What is the value of pi by 4 next? Sine of pi by 4, that is sine of pi by 4 plus cos of pi by 4 by 2. It can be solved as 1 by 2, that is becomes sine of pi by 4 plus cos of pi by 8. If I further simplify this term, I have to find out the values of this, that is sine of pi by 4. Sine of pi divided by 4 gives me the value of 1 by root 2. That is pi by 4 is 1 by root 2 plus cos of pi by 8. What is the value of that cos of pi by 8? Let me show you that. Cos of pi divided by 8. What is the value of pi by 8? It is 0.9238795325. Then what is the value of 1 by root 2? 1 by root 2. That is sine of pi by 4. 0.7071067812 plus 0.9238795320. If I simplify and further add up these values, what is the value I am going to get? 0.9238795320. If that is the case, I'll get the value which is equal to, what is the value of x0 initially? It is 0, 1, that is pi by 4, pi by 2. What is the value of y0? Y0 is what? 0. If I substitute that, I'll get the value 0. What is the value of y1? If that is the case, pi by 4, this turns out to be the value of 1.63098. What is the value of pi by 2? If I do that simplification, that is for that problem, sine of pi by 2, that is 90, which is equal to 1, plus cos of pi by 2 plus by 2, that is cos of pi by 2 by 2, which can be further simplified as cos of pi by 2 into 1 by 2, which is equal to pi by 4, plus sine of pi by 2, which is same as 1 plus this term, pi by 4. What is the value of pi by 4? Cos of pi divided by 4, that leads to the value which is equal to 1 by root 2, that is equal to 0.7071. If I add up these two terms, 1.7071, 1.7071. This is the value I am getting here. If that is the case, what is the value after plotting these terms onto the graph? If I plot the term for this cos function, it is like this for cos function. For the other function, that is sine of x plus cos of x by 2. If I do this operation, what is the value I get? First, when the value of x equal to 0, y is also equal to 0. When the value of x equal to pi by 4, that is this pi by 4. What is the value of x? That is pi by 2. When the value of x equal to pi by 4, what is the value we have obtained? 1.3098, 1.63098. 1.63098. I will get the value somewhere here for pi by 4. For pi by 2, what is the value I have obtained? 1.7071. That is this, somewhere here. This is the data point I am getting. So if I draw the curve, what happens? When x equal to 0, y equal to 0. When x equal to 1, x equal to pi by 4, it is 1.63 something. When x equal to pi by 2, it is 1.7071. So this is how the curve goes. But in this case, the curve goes like this. So y equal to, what is the value of y? Y is equal to P2 of x. It depends on this. Which is the value that is representing the value of y? This is the value that is representing the function, cos function. Y is equal to this function. This indicates y is equal to cos of x. This indicates, the dotted line indicates y is equal to P2 of x. That means, what is the meaning of P2 here? It is an interpolated value, quadratic interpolation. As a result of quadratic interpolation, I am getting the curve like this. I am redrawing the curve like this using the function of y is equal to cos of x is the function given here. Through the interpolation method, I have obtained y is equal to cos of pi by 4, pi by 2. All those things will solve the value of y0, y1, y2. That is how we are going to predict the curves. If that is the case, let me move on to the next thing. That is, what is p of x? P of x can be written as a0 plus a1x, a1 e to the power of x plus a2 e to the power of 2x plus so on up to a3 an e to the power of nx. That is the term we are going to use here. The data may be generated from this function of the form like this. If that is the case, xi, yi are the data points whose functions defines the values of that. Then we need to find the coefficients of aj based on the given data values, that is xi, yi. That is xi, yi determines the value of that. If you want to take function values f of x given in the table for selected values of x, often equally spaced and extend the function to values of x not in the table. For example, given numbers from a table of logarithms, estimate the logarithm of a number x not in the table. That is, we have to find out the value of x which is not in the logarithmic table, log table. Given a set of data points xi, yi, find a curve passing through these points that are pleasing to the eye. In fact, this is what is done continually with computer graphics. How do we connect a set of points to make a smooth curve? Connecting them with straight line segments will often give a curve with many corners, whereas what was intended was a smooth curve. In the previous slide, you have seen that if I connect these points by a straight line, what happens? You will get many corner points at this point, at this point, at this point of junction. I do not want to have the sharp corner points. Instead, I want to have a smooth curve which extends and connects these points. So if that is the case, which method is best suitable for that? Interpolation. How does the interpolation work here? Let us work out through the integration. That is, connecting the data points is called as an interpolation. Interpolating the values of one data point with the values of another data point is called as interpolation. Let us see to the example, that is I is equal to 1 plus x, integration 0 to 1 plus x to the power of 10 dx. I am doing the function of this, that is an integration I is equal to this. What is the value of this? 1 plus x power 10. If that is the case, what is the value of 0 when it is equal to x0? There must be some values. It is very difficult to do that analytically. We can do at producing polynomial interpolants of the integrand and polynomials using the integration method, that is integrated exactly. So this is the term going to be integrated. If that is the case, this becomes an integrand. This becomes an integrand. If that is the case, dx is the function that is helping me to do the integration of this term, 1 plus x to the power of 10. Suppose if there is a case called x0 and y0, what is the value of x0 then? 0, 1, 2, 3. If that is the case, what is the value of this? x0 is equal to 0, 1 plus 0, 0 to the power of 10 is 0. The value of y becomes 1. 1 plus 1 to the power of 10, it becomes 1 plus 1, 2. This becomes 2. 2 to the power of 10, that leads to some value. Let me take you into that. 2 raised to the power of 10. 1024. That is 1024 plus 1, 1025 I have. Similarly for 3, 1 plus 3 to the power of 10. 59049. 59049. So it is moving on in terms of what? When the value of x equal to 0, it is 1. When the value of x equal to 1, it is 2. When the value of x equal to 2, it is 1025. When the value of x equal to 3, it is 59,049. So there is a change in value of y for every change in value of x. What is the order of change in value? Order of change in value. You people might have seen the order of change in value in terms of time complexity. Similarly, in terms of these values of x and y, how can I determine that? That is whether it is a cubic, whether it is a exponential, whether it is a 2 raised to the power of n, or it may be anything like that. That is defined in terms of that. If that is the case, initially when the value of x equal to 0, it is 1. It is 1, 2. It is very linear. It is very linear. Later it is becoming cubic, exponential, and all those things. So it is growing rapidly at the later point of time. So we can do the calculations very easily like this. So this is how we are going to do the integration between 0 and 1. Between 0 and 1, what happens? I have only, when the value of x equal to 0, I have value of y equal to 1. When the value of x equal to 1, I have value of y is equal to 2. That's all. That's all we are going to do that. If that is the case, we have to find out the value of this through Lagrange's interpolation. Then interpolation and extrapolation differences. Interpolation. It is the method used for using the function to predict the values of the dependent variable. Which is the dependent variable? Y. Y is dependent on x, or an independent variable x that lies within the data set. This works within the given data set. Whereas in case of extrapolation, it is a method of using our function to predict the value of the dependent variable for an independent variable that lies outside the range of our data. This works beyond the given data set. Please understand it carefully here. The dependent variable for an independent variable. We are going to predict the value of the dependent variable from the independent variable in case of interpolation. In case of extrapolation, we are going to predict the value of the dependent variable for an independent variable that lies outside the range of our data. Please listen to it carefully here. That lies outside the range of data, but this lies within the data set. This is the difference between the interpolation and extrapolation. Thank you very much. Thank you one and all. Lagrange's interpolation is also available in your syllabus, which is covered in today's session. Thank you very much. Thank you one and all.